Hello friends, today I'm going to solve LeetCode problem number 319 bulb switcher. In this problem we are given n bulbs, all of them are initially off. And now in our first round we turn all the bulbs on. And then in second round we turn off every single bulb. And then in third round we toggle every third bulb, and then in the ith round we toggle every ith bulb. So finally in the nth round we'll just toggle the last bulb, and we return the total number of bulbs that are turned on after n number of rounds. So here we are given an example. So in the first, initially all of them are off. In the first round we turn all of these on. Okay, in the second round now we turn off the second bulb. Well, basically we are toggling this all the second bulb. So now here, since this is the second bulb, it's on, so we turn it off, and then there is no other like second bulb to this, right? So that's all about second round. The third round we toggle the third bulb. So the third bulb is this one, which was on in second round, so we turn it off in the third round. So since we had three number of bulbs and we did all the three rounds, so after that three rounds the number of bulbs that are turned on is equals to 1, right? So that is our output here. So this is the example for this problem. Now how could we solve this problem? Where we could approach this problem using mathematical approach. We should solve this in a constant time complexity. This problem could be solved by using like iterative approach, but that would be O of n squared time complexity. So we are going to use the mathematical one, that is constant time complexity. So let's take some bulbs. All right, so we have a bulb 1 2 3 and 4 5 6. Okay, so we are just going to take 6 bulbs here. Now all of these are initially off. Okay, so all of these are off. I'll represent off with a 0 and on with a 1. So since all of these are 0, these are all off. Now in our first round we are going to toggle all of these bulb, right? So we toggle every first bulb. So this is our first bulb, we toggle it, so it's now turned on. We toggle this one, so it's now turned on. So basically in the first round we are just turning on all the bulbs because all of them are off. Now next in our second round we are toggling all the second bulbs, right? So that means this would stay on. This is the second bulb, it will turn off, and then this would stay on. The second to this will turn off. Now again this would stay on and this would turn off, right? Now in our third round we are going to toggle the third bulb. So this is the first bulb, second bulb, and this is the third bulb, so we toggle this. Now this is the first one. After third we just begin our count again. So this is the first one, this is the second one, and this is the third one, so we toggle this, right? So we toggle this to bulb. Now the number of bulbs remaining on is 2, right, in this case. Now let's move to our fourth round. In fourth round we are just toggling the fourth bulb. So all of these will remain same. The fourth bulb will only be toggled, so it is equals to 1, and these will be equals to 1 and 1, that is they are the same. Now in our fifth round we toggle the fifth bulb. So basically all the first 4 bulbs will remain as it is, and the fifth bulb will change. So this will be equals to 0, and this one won't change. Now our sixth round, only the sixth bulb will change, so all the other bulbs will remain the same. The last one, which is the sixth one, will change, right? So this will change to 0. So basically here all of these are the same. Here all of these are the same except this one, because this only this changed, right? And so on. So while we are toggling here, the number of bulbs that's turned on at the end is equals to 2, right? So now let's see. In our first round we toggled all of them on, so there were one for each, that is each of the bulbs were toggled, so every bulb was toggled, right? So we switched all once, so operation was performed once on all of them. In the second round we performed operations on only these one, right? So that meant that the first bulb was toggled only once, and then in these many rounds these were all toggled twice. In the third round these two remained the same, only these were toggled, right? In the fourth round the three of them remained the same, as you could see here, only three of these were toggled, like not all of these were toggled, but right, the fourth, starting from the fourth, right? So in the fifth round we performed toggle, we didn't change any of these. In the sixth round only this was toggled. So how many times was 6 toggled? Let's check. So it was toggled once, twice, and then from here thrice, right? So 6 was toggled 3 times. How many times was 5 toggled? It was toggled from okay, so this is actually 4, because if we count from the round initial state to round 1, so that will be equals to 4. And then for this case as well, so we toggled once and then it remained the same, and then we again toggled, so twice, so we toggled this twice, only 2 times. And now let's see this. So we toggled it once and twice and then remained same 3 times, so it was toggled 3 times. And this was toggled once and then twice, and then it was only toggled twice, and this was also toggled twice, and this was toggled only once, right? So the number of toggles that are odd are 1 for bulb 1 and for bulb number 4. This is the bulb number 4 and this is the bulb number 1. So only these two were toggled odd number of times. So what happens if you toggle it odd number of times? Well, it will remain turned on at the end, right? If you see, like we are turning it on from an off state, so from off to on it is one toggle and it's turning it on, right? So similarly for this it's 3 times, which means that from off we are turning it on and then we turned it off again and then we turn it on again. So at the last round it's on. So only those bulbs which were toggled odd number of times will be turned on at the end of the round, all the rounds, right? So which are those? 1 and 4. If we look at this carefully, if we have more number of bulbs, then you would actually see that only those bulbs which are a square, which are perfect square, are turned on. So if there were 15 bulbs, then all the bulbs which are perfect square. So what are perfect square? 1 is a perfect square, 4 is a perfect square, 9 is a perfect square, and 16 is a perfect square, 25 is a perfect square, and so on. So if we had 15 bulbs, then bulb number 1, 4 and 9 would be turned on at the end. So that means there will be 3 bulbs that will be turned on. All right, so the result would actually be the total number of bulbs, 15 square root of this value. Why? the square root of 15 is equals to 3 point some value, right? Some value, because we know square root of 16 is equals to 4, square root of 9 is equals to 3, so square root of 15, which lies between 9 and 16, is equals to 3 point something, but we are taking just a floor value, so we will actually get the value 3, which is the number of bulbs that will be remained on, right? So that is our formula. So our formula is just one line. It's just the concept that we need to understand, which takes time, but the formula is just a single line. That is, we are just going to take the floor value of the square root of the total number of bulbs. That's it. So let's just code our result very quick. So that would be the floor of the square root of n. That's it. Now let's run our code and see if it works fine. Awesome, this works very well. Let's submit this. Great. So this was just an of one time complexity solution. I also tried an iterative solution, which is O of n squared, but I got a runtime error for this solution. So you could just come and check my solution, but yeah, this one is O of one time complexity solution. Hope you liked my solution. Let me know in the comments down below. Thank you.